So first, the good news. This talk will be pretty short. And then the bad news, I have a pretty cheap laptop. Which means I either see the picture here or here. Which means I have to switch between transparencies. But since I have foreseen that, it worked before.
This is not German techno.
Yeah, but it's problematic. I have to click on these. And so I think, okay, you need some patience at least. Okay, so this is the first report on the International Detector R&D panel. And since it's the first report, it will be a rather preliminary report, of course, because we are not very, very far advanced. And therefore, I thought, because there are many new faces here, I should give a short, comprehensive summary why we should do R&D for linear collider detectors. Okay. Okay, so why do we need linear collider detector R&D at all? And I don't want to go into much detail here. You should really look at the talks by Keith Riles, Ray Frey, Gene Fisk, and in that context, to some extent, also to Norman Graf's talk. But the first three really describe the reasons why we should do R&D and what R&D is going on. Well, in a nutshell, high precision measurements at the linear collider requires, to my mind at least, and there I make even a stronger statement than Keith on Monday, a much better detector performance compared to lab and SLC detectors. And it's not only the resolution itself, but it's also the systematics. The resolution, improvement in resolution doesn't help you enough if you don't have the systematics in hand. And therefore, you really need a good detector. Now, why do we need it? Now, some demanding examples are as follows. Flavor tagging. And at flavor tagging, it's not only the B tagging, which we are used to, it's the charm tag. And that's the challenge. Higgs to CC bar is an example. Multi-jet final states are examples, like top final states containing top and W's. I mean, there you really need an excellent vertex resolution. I mean, all these examples, you can have many more examples, I only list a few. Momentum resolution. The Higgs signal from dilepton recoil mass is very important. There you need a very good momentum resolution. And endpoint mass spectra and SUSY cascades, as was pointed out by Keith. Okay, jet reconstruction. I think this is one of the most demanding things. The energy flow. This is something new which we have to do there. Why do we need it? The Higgs self-coupling in HHZ, as you heard before, it needs a lot of luminosity. But it also needs the best possible detector you can achieve, especially in calorimetry and the mix of calorimetry and tracking. EE to ZZ nu bar, WW nu bar, to distinguish these things. Ray Frey has shown these plots on Monday. So there you really see you need the best possible energy flow measurement you can do. Multi-jet final states, TT by H. And here one should not forget the effect of shower leakage. I mean, it's nice to have some very nice small distributions, but don't forget the tails. They can destroy everything. So one has to think about the muon system as acting as a tail catcher. Forward angle coverage. You might have new T-channel processes, so you really would like to go to the smallest possible polar angles in coverage. And you need to measure the differential luminosity, the luminosity spectrum. There you need very good angular measurement in the forward direction. Then, beside the detector itself, there are other things which influence the physics. Beam energy determination. If you want to do threshold scans, and if you want to go to GigaZ, that's a demanding thing on the beam energy determination. Don't forget polarization measurement. It will be vital, especially once we go to gigaset. And then another chapter is the interaction region issues. Masks and the mask instrumentation itself in order to really go down to low polar angle, hermeticity. Diagnostic detectors. And not to forget photon collider issues. Up to now, mostly we have studied the E plus E minus, but don't forget the photon collider issues. I was not sure if you had something against my statements here. Okay, all these topics together, if you do it into a simulation, then the present simulation study suggests following performance figures. For the vertexing, impact parameter resolution in R phi and in Z below 5 micrometer. This is not a huge step from the present one. But, I mean, we are already close to the limit. So I think it's very difficult to achieve that. For the tracking, momentum resolution better than 5 times 10 to the minus 5. I think that's roughly 1 order of magnitude better than the lab detectors have done. And don't forget, here you need a systematics which is not so easy to achieve. So all this needs studies. For the energy flow, this is a factor 2 or more what we have to get better compared to the best one at lab, namely Aleph. And without that, you cannot do very easily the triple Higgs coupling. For hermeticity, we need, as I said, excellent forward coverage with a beam pipe as really the only hole. And this should be of the order of 10 millirad or less in the whole 4 pi acceptance. And you have to instrument that, of course. For background robustness, you need fine granularity in all subdetectors, so you have to interplay the granularity and the cost. And a large B field, at least 3 Tesla. All the regions have now at least 3 Tesla. For the beam energy determination, at high energies, 10 to the minus 4 is okay. So that I think we can achieve. But if you, for example, go to gigaset or to the W threshold especially, you need 10 to the minus 5, and that's a challenge. And for the polarization, percent to below per mil what we need, especially again when we go to gigaset. So all this I think is not so easy to achieve. Hey, my mistake. Shit. Okay, so I think with all these performance figures which I showed, it's obvious that the performance of a lab or SRC detector is not sufficient. We need, as Keith expressed it, a more aggressive detector design and also possibly new technologies and, I hope, also new ideas. Can we benefit from R&D for LHC detectors? The answer is yes, of course we can benefit, but don't forget that physics and the nature of the events at LHC and at linear collider are completely different. So the linear collider experiments will require different optimizations and different detector choices. So there's a clear need for linear collider detector R&D coupled with detector-oriented simulation studies and the development of new algorithms. And a very good example here, where you have the interplay of all these three, is the energy flow. You have to develop the method together with the proof that you can do the technology you need for this method. And the time scale, and this is something, I mean, time is running out now. We have to get our act together. We want to form experimental collaborations around 2005. I mean, the HEPUB sub-panel mentioned 2005. In the talk just before the coffee break, you heard 2006, the machine could start being constructed. So we should not be later than the machine. So that's 3 to 4 years. So better get going. Also with this. Okay, so we are already getting going. So what is the present status on linear collider detector R&D? Now here I refer you again for the details to Jim's, Gene's, and Keith's talks. They are ongoing in Asia, Europe, and North America. However, they are ongoing on there are different level of activities. There are different emphases. For example, in North America, the main emphasis at the moment was on simulations. There's more emphasis in Europe, and I think to some extent also in Asia, on hardware R&D. But mostly all this R&D which is going on is individual groups or regional projects. However, the detector designs are to first order independent of the machine designs under consideration. The only real exception is the bunch spacing. This is different, and that has to be taken into account. But otherwise, to first extent, they are similar. Funding and human resources are tight, and that's regional independent. So we should try to avoid unnecessary duplication. And then, as Paul has pointed out on Monday, test beams are scattered around the world, so why not working together around the world? And I think we can and we should work together. And we have existing interregional projects. And I know of 4 examples. Well, one is a project on TPC studies, which is interregional between Europe and North America. And you see, I make a fine distinction between North America and US. Because in the TPC part, we have the US and Canada together with Europe. Canada, we have Carleton University. In the US, we have MIT and Berkeley together with Europe. Then we have the calorimeter studies. This is Europe-US. And in the US, it's Argonne, which just has joined these studies. In the interaction region designs, there's development of diagnostic detectors, and we have heard yesterday evening in the town meeting from David that Europe and North America are working together. And here again, it's North America because it's UPC, and in Europe, and it is Oxford. And then a new development is a laser system for the gamma-gamma interaction region, where Europe and the US are starting to work together in order not to duplicate work. And this is, in Europe, the Max Born Institute in Berlin, and in the US, Lawrence Livermore. So there are examples that you can do it once you want to do it. So the question is, do you want to do it? And the answer has to be yes. Well, at least my answer is yes. Yes. So, how to go from here to interregional linear collider detector R&D? What are the plans? Now, in Rome, last year it was suggested by the Worldwide Study Organizing Committee to organize the R&D efforts a bit more globally and to facilitate in this way and to foster interregional cooperation and collaborations. So the organizing committee set up a panel with 3 members from each region, and the members are Yoshiaki Fuji, Wanbei Park, Hitoshi Yamamoto from Asia, Christopher Ron Settles, myself from Europe, Jim Brow, Gene Fisk, Keith Rice from North America. Now the group met with varying composition in Krakow, the European meeting, Beijing, the Asian meeting, and here in Chicago. Our aim was to produce a first report by mid-February, but there was a problem. And the problem is this, the varying composition. In Krakow, due to the September 11th events, only the Europeans were present. Plus some representatives which are not on that list from the US and from Japan. So there we discussed what to do, essentially, with this report, with this international R&D. Then in Beijing, again, there were 3 Asians and 1 poor guy from Europe. And here we have the North Americans, all the Europeans, and 1 Asian. So here it was really the first time that we had all 3 regions together. And we met on Sunday afternoon. So this is a rather fresh report. So we cannot make the first report by mid-February. However, what should this report do? Well, it should first describe the required detector performance along the lines I have shown in my first transparencies and the challenges, and point out the need for R&D. Then list the R&D efforts which are presently going on, and as a last point, point out areas where effort is missing or areas which are not adequately covered. Yeah, as a first step. But this report is, of course, not meant to be prescriptive. We are not the gurus. There will be areas of R&D not mentioned in the report. And there will be hopefully novel ideas we don't know yet. However, what we try to do from the very beginning, and we achieve this, I think, the report is structured according to subdetectors or R&D items, not according to regions. This was the first achievement which we got. That means within the individual R&D topics, regional and interregional projects will be listed with short descriptions, very short, also pointing out their similarities as well as their complementarities, and with links to web pages, which are, of course, encouraged. All projects should have web pages, because otherwise you don't have the information flowing. So this is I really stress this point, that we structure it according to the items and not according to the regions. So what is the status of the report as of today? Well, items 1 and 2 are sufficiently advanced. We have a list of ongoing topics. That part will be available mid-February in a preliminary version. I mean, we have to go relatively speedy, so I really want to have this there mid-February. So that should already help to improve contacts. Well, at least we will get contacts and complaints from people who are not on there. And it should help to have information exchange between the groups in different regions, because everybody can see what the other guys are doing. It should already at that point allow interested groups or individuals to join ongoing projects or initiate new projects, because they see where the holes are. Now, in order to identify all the holes, all the missing efforts, which is item 3, which I would like to have, if possible, prioritized, more information about the ongoing projects is needed, because we have to see what state they are in. And there we aim, at least I aim, for end of March. I hope that we get it out end of March. But the problem with such a report is that it's static. We cannot go through that thing every half a year or so. So we need a more dynamic tool. Here, also here. So a more dynamic tool, of course, is a web. So the proposal is we would like to create and, in red, maintain the web pages which are structured in the same or in a similar way as the report is structured. That means an overview page linked from the World Study web page, which contains general detector R&D information. That has then links to subdetector or topic-related pages, of which we want to define the structure and the content to some extent, what should be in there. So we would like to have it a bit in a unified way. These subdetector and topic-related pages have then links to the individual project pages. And that, a web page of this type, makes only sense when it's up to date, everywhere. So the maintenance responsibility will be with the panel members here for the overview, who then have to kick the regional contact persons in order to maintain the subdetector or topic-related ones, who then have to kick the project leaders to keep the individual project pages up to date. Now, in this way, we would have up-to-date information about ongoing and missing R&D efforts all the time. Crucial is really the maintenance of these pages. Now, once we have this, I think everybody can go and get things going according to the information there. You can plug in, you can inform yourself what's going on, you can contact your colleagues, and I think that would be the first way to really get people. But it must be you who moves. It's not us who is moving you. You have to move yourself. You have to contact your partners in the other regions. And I think that's what we really have to do. And that should help you. And since this is my last but one transparency, and you see the talk is really short, I would like to get some feedback from the audience here, what we should do in addition to that, but then we need help. Or if you have other ideas. So, summary. An international linear collider detector R&D panel has been set up. A status report is in preparation. We have proposed the structure for a web-based R&D information. As I said, comments and suggestions are welcome. My aim and hope is that we achieve in this way more information exchange between the individual projects, that we encourage closer interregional cooperation and even collaboration on individual sub-detector or R&D items. We should not go in our cooperation or collaboration regional-wise, we should go sub-detector or item-wise. That's very, very important to my mind. And to my mind, the time is ripe. And let's make detector R&D more global. Thank you.
So we have still time for discussion, as Wolf asked, and so first.
Hi. It seems that right now is a time when a number of us who haven't really worked in NLC detector stuff before are starting to think about what we might like to do. So if you have actually a fairly long list of things to look at, to think about, that are in need of attention, that might help us as we start to decide which way we're going, actually think about what we would like to be doing. So more detail, longer lists would be great.
Yeah, but that's the purpose of the panel. Of course, we will produce this. I couldn't give it here because we don't have it.
No, I understand. When you have your websites up, having it be very detailed, lots of nuts and bolts would be a terrific thing.
It will come, but I mean, you must give the people also time to prepare these websites.
Sure.
Yeah. Yeah.
I just wanted to say that I think that this would be a good time to say that the web structure of the American part of the collaboration needs revamping. And maybe it's best done in the context of what Rolf just said. Basically, when I go to look for something having to do with the detector, I either go to Paul Granis's webpage, Mike Peskin's webpage, the one that John Jaros and Norman Graff, or the one that Charlie Bolte maintains at Yale. And somehow, and some of them are up to date, some of them are not. It's not complete, sort of a bit of a mess. And maintenance of these things is the hard, part.
This I want to avoid here with this large interregional one. I mean, there everybody can plug in their own things, but it should go through the contact persons per region, and it has to be maintained. Nothing is worse than an old, out-of-date web page, because nobody will join into such a program.
So somehow the people who control sort of computing resources and people who can maintain these pages have to step up and volunteer to take on this responsibility regionally or something.
I mean, you can be sure we will do this in Europe.
Rolf, it may not be clear to everyone what test beam facilities exist, what the parameters are, and what the time availability will be. Are you going to try to summarize that?
It would be nice if you could send me a list of what you know. But at some stage we will make that available too. Yeah, we have to. I agree. But input is welcome, Paul. Don't hesitate.
Other comment? Mike? Yeah.
I just wanted to comment that some of the linear collider R&D that we started on is becoming more generic. For example, in the TPC area, we started on with the linear collider-specific R&D plans, but then we found that the RIC experiments are planning to do some upgrades. So we went to a Brookhaven meeting in November where we talk about more generic work. So in specifying the things that could be done in this R&D activity, I think is a little short-sighted, because I think once you get into it, you find many more things that could come out of what we're doing. The LHC R&D effort, which was very impressive, was not an end-all to R&D for the future. And so, please join in. There's a lot of different projects. I don't think Rolf can give you a list, because I think the list is changing dynamically. It's all the time. And so getting involved in the work, you'll add to the list, or you'll develop your new other directions to go in. So, okay.
Well, surely, I mean, the list is one thing, but I think your imagination is something else. You can also come up with topics which are not on the list. Yeah, that's what I said. I mean, clearly.
I'd like to propose something innovative in the way that we attack some of these projects. What more internationalization could we have than to create pots of money a la CERN that are internationally repositories of money, which might really force our funding agencies to think about this seriously as an international effort. If it's development money, this might not be so large as to scare away the politicians.
Okay, but then you need a body which distributes that money. But, I mean, I think it might be a good suggestion. It's a good suggestion. We can try. I mean, I think we should try whatever we can. After all, we want that thing, right? Yeah? Okay. So we should do something for it.
No more comments? So let's thank Rolf again.